In this video, we're going to look at a more theoretical example of areas between curves. So here we have find the values of C, constant C, such that the area of the region bounded by the parabolas x equals c squared minus y squared and x equals y squared minus c squared is 72. This is an inverse type of question because we're usually asked to find the area. Here we're given the area and we have to work backwards and find the constant C. So the first step, like usual, is find the intersection point of x equals c squared minus y squared and x equals y squared minus c squared. So we're going to let x be equal to x and solve for y. X equals x, so we have c squared minus y squared is equal to y squared minus c squared. Bring the c squared over and we get 2c squared on the left hand side and add y squared to both sides and we get 2y squared on the right hand side. Divide both sides by 2 and we get y squared is equal to c squared. Solve for y and we're going to get y is equal to plus or minus c. Solve for x, we can put it into either equation, it's all the same. X is y squared minus c squared and we get x is equal to c squared minus c squared equals 0. And it doesn't matter whether you put a plus or minus because it's getting squared and becomes positive. So the intersection points are x equals 0, y equals c, and x equals 0, y equals minus c. Let me write that better, minus c, and these are the intersection points. All right, let's look at a sketch. So we can see that x equals y squared minus c squared is a parabola that opens to the right, and x equals c squared minus y squared is a parabola that opens to the left, and they intersect at the points that we found at x equals 0, y equals c, x equals 0, y equals minus c. Now, it's logical to draw a horizontal slice because that way we can capture the whole area with one integral because the right point of contact is always going to be the parabola x equals c squared minus y squared, and the left point of contact will always be x equals y squared minus c squared. So if we set up the definite integral, it's going to be integrate from minus c to c. These are the y values, and we go x right minus x left. X right is going to be c squared minus y squared, and x left is going to be y squared minus c squared dy. All right, so now we're going to do this more formally in the next step, and the differential area is going to be c squared minus y squared. If we simplify this, we get 2c squared minus 2y squared dy. We add up these horizontal slices in the y direction. That's what the integral does. It adds up the slices and we add them up in the vertical direction, I should say, in the direction of the y-axis, and we capture the entire area. All right, so let's set up the definite integral and solve for c. The area is going to be integrated from minus c to c differential a. That's equal to area is equal to integrate from minus c to c. And we simplified it before, that's 2c squared minus 2y squared dy. Make this equal to 72. We're going to integrate and solve for the value of c such that the total area is 72. Now, because the region is symmetric with respect to the x-axis, let's look at the picture and actually show that. You can see how this region is symmetric with respect to the x-axis. So we only need half of it, and we're just going to multiply by 2. So area is going to be 2 times integrate from 0 to c, 2c squared minus 2y squared dy equals to 72. All right, let's integrate this. Area is going to be equal to 2 times integrate 2c squared, and we get 2c squared y, because 2c squared is just a constant, minus integrate 2y squared, we get minus 2y cubed divided by 3. Evaluate it from 0 to c, and this whole area is 72. Apply the fundamental theorem of calculus, put the upper limit in, subtract the lower limit, we get area is equal to 2 times we get 2c squared times c, that's c cubed, minus 2c cubed over 3. Now plug the lower limit in, we get 2c squared times 0, that's just 0, minus 2 over 3 times 0 cubed, that's 0 again. And if we simplify this and make this equal to 72, let's simplify, we get 4c cubed minus 4c cubed over 3 is equal to 72. We'll solve it on the next page. All right, so what we have is area is equal to 4c cubed minus 4c cubed divided by 3 is equal to 72. Let's take common denominator. The common denominator is 3. And 1 goes into 3 3 times. 3 times 4, that's 12c cubed in the numerator. Minus 3 goes in 3 1 time, we get minus 4c cubed. That's equal to 72. And 12c cubed minus 4c cubed gives us 8c cubed. Divide by 3 equals 72. Now multiply both sides by 3 over 8. We get c cubed is 72 times 3 over 8. Well, 8 goes into 72 9 times, so we get c cubed is equal to 9 times 3, that's 27. Now take the third root of both sides. Third root of c cubed is equal to third root of 27. So we get c is equal to, and third root of 27 is 3. So what that means is for the total area of the bounded region, let me write that in, the bounded region, to be 72, the value of the constant c must be 3. That means when c is equal to 3, the whole area is 72. And by the area, of course, we mean the shaded region here in this diagram. This shaded area is 72 if the constant c has a value of 3. All right, thank you.